What we're going to learn here is a new method of factoring. Let's begin. In this first problem, we're going to factor 3y times 2x minus 7 minus 8 times 2x minus 7. Now notice again, we don't have a product, but we have a difference. We have the minus sign between the two terms. So what we're going to do is look at each of these terms. Here's 1 and here's 2, and decide what do these two terms have in common. So we'll write that out as the common factor, 2x minus 7. Now 2x minus 7 times what will get me back this 3y times 2x minus 7? Well, the only thing missing is the 3y, so we write it in. This times 2x minus 7 gives us back our first term. Now we just have to worry about our second term here. 2x minus 7 times what will give me negative 8 times 2x minus 7. Well, that looks pretty easy. It's only missing that negative 8. So there we've taken a difference and rewritten it as a product, so we're in factored form. Now let's see what the difference is between the first and the second problems. For one thing, no parentheses. We have a list of terms. We have 6x squared minus 15x plus 4x minus 10. In this problem, we're going to show how to factor by this thing we call grouping. Now, factor by grouping means exactly as it sounds. We're going to group the terms 2 by 2. So I'll put a line under the first two and under the second two. Those are our two groups. Now, within just the first two, pretend that the second two aren't even there. Within the first two terms, what is the greatest common factor? Well, between 6x squared and 15x, don't worry about the negative sign at this time, the greatest common factor happens to be 3, and they both have at least an x, so it's 3x. That's the GCF between the first two. Now, I'm going to go through the same procedure as I did in the previous problem and ask myself 3x times what is 6x squared? Well, how about 3x times 2x? So these two give me my first term back. And then to get my 15x here, I'm going to multiply 3x by negative 5 to get my 15x. So notice if I multiply or if I distribute in this first set, 6x squared minus 15x, I get those first two terms back. Let's do the same procedure on these next two terms. Plus GCF between 4x and 10, 2. So we'll pull that out. 2 times what is 4x? How about 2 times 2x? Minus, because I know I'm going to have a negative product there. 2 times what is negative 10? How about 2 times negative 5? So there we have it. Now you might say, now where are you going to go? Well, look here at where we are and look up here at the previous problem. Do they look the same? They sure do. We've got here one term, here a second term, and we've got a sum. In order to completely factor this, we have to write it as a product. So we look at the first two terms, just as we did up here, and we notice that they have something in common. So we're going to come down here, 2x minus 5, which is common to the first term and to the second term. To get the first term back, you should be getting the good at this now. All we have to do is multiply by 3x. To get the second one back, all we have to do is multiply by 2. So we write plus 2 here. Notice again, we end up with a product, which is considered factored form. So the procedure we went through in the second problem is called factoring by grouping, and you factor by grouping the first two together and the second two together, finding that greatest common factor within each pair, noticing that we have a common factor once we write it in this form, putting it out front, and then finishing it off. Let's look at some more factoring by grouping. We're going to factor the following: ax plus 2a plus 4bx plus 8b. Now, one of the things that you should get used to doing is when you approach a factoring problem, you should always keep your eye out for a greatest common factor amongst all your terms. So let's look and see. Let's make a quick check. Is there any term that is common to all those 4 terms? Well, we almost had a 2, but this first one's lacking in numbers, so that can't be part of the GCF. We don't have x's everywhere, neither do we have a's or b's everywhere. So there is no greatest common factor. So please make it a habit when approaching a factoring problem, the first step, check for a GCF. Now the second step. Many students get confused because they don't know which factoring method to count the number of terms. 1, 2, 3, 4. Whenever you're given 4 terms separated like this and they ask you to factor, all you have to do is think 4 terms, factor by grouping. So let's begin the procedure. Remember, factoring by grouping means we're going to group the 4 terms 2 by 2. The first 2 become a pair and the second 2 become a pair. Within each of these pairs, we're going to look for the greatest common factor. So within these first 2, I see that they both have a common factor of a. So I'm going to write that out front and ask myself as usual, a times what is ax? A times x is ax. Plus a times what is 2a? How about a times 2? Again, I could check to make sure I factored correctly by applying the distributive property. A times x, ax. A times 2, 2a. And I factored correctly. Same thing to the second pair. 4bx plus 8b. Look for the GCF. Is it standing out? We can see that they both have a 4 in common. They both have a b in common. So 4b would be the GCF. Let's write that down. 4b, parentheses, 4b times what gives me 4bx? It's only missing the x. 4b times what gives me 8b? How about plus 2? Now, another key to factoring by grouping is this. Once you get to this step, these 2 terms in the parentheses must match up exactly. If they don't, then you haven't done something quite correctly. So let's continue. Since ours do match, that is the common factor between the 2 terms. So we'll write it as x plus 2. And hopefully you're getting the hang of this now. What goes in my second set of parentheses? Just the a plus 4b. So again, what we did is we started with an expression with 4 different terms. Notice it was a sum, and we rewrote it as a product, and that procedure is called factoring. So x plus 2 times a plus 4b is the factored form of this original expression. Let's try our second example. Again, I want you to get in the habit of when you're factoring to always look for the GCF amongst all 4 terms first, because sometimes it might be there. So let's check. I have 6, 14, 15. I can already tell I'm not going to have a GCF numerically. Let's check the variables. I've got an x, oops, I've got a y there, so no x in common and no y in common either. So we're assured that there's no GCF amongst those 4. Now again, count the number of terms. We just said there were 4. Whenever you see 4 terms and you're asked to factor, think factor by grouping. So again, let's try to group these 2 together, the first 2 and the second 2. Within the first 2 terms, what is the GCF? Well, I see that they're both even. I've got 6 and 14, so they at least have a 2 in common. Is there anything else? 6 and 14? Nope, that does it, so we'll take out the 2. I see that they both have an x in common, so that also becomes a part of my GCF, and there's nothing else in common. So we're ready to write the parenthesis. 2x times what is 6xy? Well, I need a 3 to get a product of 6. I've got my x taken care of, so I need to add the y there. Plus 2x times what is 14x? Looks like we need a 7. 2 times 7 is 14x. So there's the first pair. The same procedure with the second pair now. 15 and 35. Now, here's where you have to make a decision. Remember what I said in the previous problem. I said if you're factoring by grouping, one of the keys is to make sure that whatever ends up in the parentheses here must match up exactly, because if it doesn't, then it will not be a common factor amongst the two terms. So, why am I mentioning that at this time? I've got in my first set of parentheses 3y plus 7. I see I have a couple of negatives coming up in my next two terms, negative 15y and negative 35. In my mind, I'm thinking, I want to get this 3y plus 7 as my second parenthesis so that I can continue in the procedure of factoring by grouping. How can I get a positive here when I've got two negatives? Well, let's think of it. How about if we factor out a negative? So instead of factoring out a positive, now between 15 and 35, the greatest common factor is 5. So instead of factoring out a positive 5, I'm going to factor out a negative 5, because watch what happens now. Because this is a negative 5 times what gives me a negative 15y? Well, that's a positive 3y. Negative times positive, negative 15y. And now my negative 5 times what's going to give me negative 35? A negative 5 times a positive 7 gives me a negative 35. Again, I made that decision because I know with my experience and your experience at this time, when you're factoring by grouping, these parentheses must match up exactly if you're going to follow the procedure of factoring by grouping. So now that these two match up exactly, we can go ahead and write that up front as the common factor between our two terms. And I know this is becoming easy for you now. What goes in our second set of parentheses? The 2x minus the 5. And there we have it. So here's our product of that polynomial above, 3y plus 7 times 2x minus 5. Again, the key to this procedure of factoring by grouping is you want to make sure that what's in these parentheses after you paired your two groups here is to make sure that these guys match up so it will then become the common factor amongst your two terms.